This is a tutorial video for the Euler-Cauchy differential equation. So, Euler-Cauchy differential equation is one type of linear equation with variable coefficients. By a simple change of independent variable, it can always be transformed into a linear equation with constant coefficients. With the equation a sub 0 x to the n y to the n plus a sub 2 x to the n minus 1 y times n to the n minus 1 plus a sub n minus 1 x y prime plus a n y is equals f of x. So, in which the coefficient of each derivative is a constant multiple of the corresponding power of the independent variable. As we shall soon see, change of the independent variable defined by x here is equal to e to the z, or z is equivalent to ln of x, wherein x in here is not equal to 0. We'll always convert this equation into a linear equation with constant coefficients. This in turn can always be solved by the methods which we have developed in the preceding sections of this chapter. So finally, by replacing z by ln of x in the solution of the transformed equation, we obtain the solution of the original differential equation. So, cite an example. We have x squared y double prime minus 3x y prime plus 3y is equals ln of x, wherein y to the minus 1 equals 9. Then y prime of minus 1 is equivalent to 1 over 3. So, first thing to do, we must get its yc. For getting the yc, or the complementary function, is x squared y double prime 3x y prime plus 3y plus ln of x. For getting its yc, it may be written as m times m minus 1 times y minus 3my plus 3y equals z, because the ln of x here is equivalent to z. And then factor out the y, it will now becomes m times m minus 1 minus 3m plus 3 times y equals z. And then the combined like terms, it will now becomes m squared minus 4m plus 3 times y equals z. So from the left in here, we set it to 0, wherein m squared minus 4m plus 3 equals z. So this equation, it is a characteristic equation. So from this equation, we have m minus 3 times m minus 1 equals 0. So now we have a value of m is equals 3, and then m is equals 1. So from this given value, we have now the complementary function. So yc is equivalent to c1 e to the 3z plus c2 e to the z. So for getting the yp, we must focus on the g of x. So g of x here is your z. So now our guesswork in here, the yp is equivalent to az plus b. For getting the value of a and b in here, we must find its y prime and its double prime. So for getting its y prime, so y prime in here is equivalent to a and then our y double prime is equivalent to 0. So from this value, we must substitute it to its characteristic equations. So now we have minus 4a plus 3az plus b cos z. So expand, it will now becomes minus 4a plus 3az plus 3b cos z. So now we must combine like terms and group of its coefficient. Now we have 3az minus z is equivalent to 4a minus 3b. So factor out the z. We have a value z times 3a minus 1 plus 4a minus 3b. So now, for getting the value of a and b here, we have 3a minus 1 equals 0. Then 4a minus 3b equals 0. So we must multiply it by minus 4, negative 4, and then from this equation we must multiply it by 3, so that the a here will be now cancelled. So we're not cancelled. Then we have here, we have now 4 minus 9b equals 0. And then our b now, we have 4 over 9. And then our a is equivalent to 1/3. And now, substitute this from this given value, substitute it to the yp. So yp now, we have yp is equals 1/3 z plus 4 over 9. So now, our complete solution will have now, we'll have y equals c1 e to the 3z plus c2 e to the z plus 1/3 z plus 4 over 9. And then turn it into its original form. It will now becomes y equals c1 x cubed plus c2x plus 1/3 ln of x plus 4 over 9. To find the value of c1 and c2 in here, we must find its a y prime. So the y prime, its the first derivative is 3c1x squared plus c2 plus 1 over 3x. So now we have a given a problem in here. If x is equals negative 1, we have y is equals 1/3. So from this given value, substitute it to the equation. To the 4 over 9. So we have 4 over 9 equals minus c1 minus c2 plus 4 over 9. And then 1/3, we have 3c1 plus c2 cos 2/3. And then the right one is x equals negative 1, then y is equals 4, 9. So we have 4, 9, substitute, cos minus c1 minus c2 plus 4 over 9. And then the two equations will be now combined. So c1 plus c2 is equals 0, and then C1 plus C2 is equals to 2/3. So, the second equation, multiply it by -1 so that the C2 in here will be now, let's see, so, have now the value of C1, so which is minus 2C1 is equals to 2/3. Now, our C1 is equals to minus 2 over 6, or equivalent to minus 1/3. And then, the value of C2 now, we have 1/3. So, from this given value, we substitute it to the complete solution. So, our complete solution now, we have y is equals minus 1/3 x cubed plus 1/3 x plus 1/3 ln of x plus 4/9.